how do we apply conservation of linear momentum through examples? Let's say there are two bodies which are coming like this purely on a horizontal frictionless surface. This body is going this way 10 meter per second and this body of mass 5 kg is moving 20 meter per second. Both the bodies are collide, stick together and move with a common velocity. What is that velocity that we have to find out? Let's say after the collision, we don't know what is the velocity, but let's say that we find out momentum before collision. We find out momentum before collision. That is, we can take this way, momentum is a vector quantity, so this way we take it as positive, and this way we can take it as negative. X-axis, you know, that is, X-axis is this way positive, this way is negative, though we can take it otherwise also, but let's use, this is a convention, so let's stick to the convention only. So momentum of this before collision is mass, we know, that is momentum is mass into velocity. Momentum is mass into velocity. So mass is a scalar quantity, velocity is a vector quantity. It has magnitude as well as direction also, so momentum is also a vector quantity. So momentum of this before collision, that is 2 into 10 positive plus mass into velocity. Velocity is in this direction, so it is mass into velocity minus 20. So this comes out to be 20, this comes out to be minus 100. So this comes out to be 80 kilogram meter per second, mass into velocity. It comes out negative. It means finally, that is initially the momentum is, net momentum is in this direction. Sum of these momenta that is in this direction. There is no external force which has been applied on the system. So what we say is that is momentum of this system is conserved. It means the initial momentum, that is momentum before the collision, should be equal to momentum after the collision. Initial momentum of this and this is coming out to be negative. It means it is net momentum is in this direction. So it means that finally also the momentum should be in this direction. When these two bodies, they are stuck together, so it is the total mass is 2 plus 5, that is 7 kg. And 7 kg should be moving in this direction. So if we say 7 into V, we have taken it in this direction, should be equal to 80. Don't say minus 80. We have already taken it as 7 into V. Minus means in this direction also. So it is 80 kilogram meter per second in this direction. So that should be equal to what? 7 into V. So V comes out to be 80 by 7 meter per second in this direction. So we get the velocity of the combined mass after the collision. We have taken this as a perfectly inelastic collision, perfectly plastic collision, that is when both the bodies, they stick together after the collision. If you are comfortable with vectors, let's use the simple application of vectors. Momentum before collision is equal to momentum after collision. What is that? So momentum before collision is 2 into 10 I cap. This way is going to be I cap, this way minus I cap, this way j cap, this way minus j cap. This is how the vectors, we know the vectors. Momentum before collision is of this is 2 into 10 I cap, of this plus 5 into minus 20 I cap, that is 20 into minus I cap, this is moving in this direction, is equal to mass. Momentum after collision, that is total mass is 7 into V vector. You don't know what is the value of V vector. So this comes out to be 20I minus 100I is equal to 7V. So this comes out to be minus 80I is equal to 7V. So V comes out to be minus 80 by 7I, that is, it is going to be, velocity is going to be 80 by 7 meter in this direction. It means the same thing.